name's Jared. This is Lauren and Eric. We're with Fundamental Technologies, and this little presentation is going to be kind of a three-part thing. I'm going to tell you a little bit about what we do as technologists relative to the industry a little bit, and then Eric's going to go into some specifics about what Fundamental actually does and talk a little bit about pipeline design and pipeline layout and construction, and then Lauren's actually going to go through a 3D CAD model and show you guys what we actually physically do when we're in the office to some extent. So I guess a little bit of background about us. I mentioned that we're technologists. Me and Eric are both certified engineering technologists with Asset of Alberta. Lauren's a technologist in training, and we're all at a little bit different parts of our careers right now. So to give you a little bit of an idea of the differences between us, Lauren came over from the East Coast, and she got out of school in 2011, I believe.
Yep, December.
And she was a graduate of the Industrial
Engineering Technology.
And so this is like second or third serious job since school, so there's a little bit of movement there. You did a co-op program. One of the things she actually worked on was, if you could bring up the FPSO there. One of her first projects working as a trainee at Husky Energy on the East Coast was to help with the design and drafting work on the turret, on the mooring turret. That big cone at the top there is actually the way that they plumb all of the subsea wells in an offshore vessel up into the FPSO. So right off the get-go, she got to do a little bit of that stuff, and I think there's a couple other photos in there to give you an idea of the kind of projects that you might get involved in doing this type of work. Eric's a graduate of Mechanical Engineering Technology 2009. He's been out of school for a little while now. Like I said, he's a CET, and you came straight out of school, went to FunTech, right? So a little bit of a rarity, but he came back to Grande Prairie and got to work and has been gainfully employed ever since. And Eric's about a year or two out of management. So to give you guys like one of the upsides of the technologies path, one of the upsides to what we do, because of our technical background and our education, we tend to get the opportunity to move up into management level positions a little bit quicker. Not quite like the engineers would, but obviously if you're interested in being a boss someday, a lot of the technical skills and some of the clerical skills and things that we learn, like technical communication at school, are things that apply to moving up the ladder. If you want to move into a management position, if you want to be a boss, if you want to start your own business, that's really important. It's something that you guys have to grasp, that there's certain skills that you're going to need, and the way that we took the path that we chose for school was something that applies well to moving towards that direction. So I know there'll be a couple of entrepreneurs in this class. You might not realize it yet, but if you decide to take the college route, there's a lot of things that they show us in school on the business side of things that'll really help you out. We've talked a lot about, Janet mentioned communication, and that's one of the things that they emphasize. Our first course, usually when you show up for the first day of college, normally the first course is technical communication. And the idea behind that class is just literally, if you can believe, you guys will spend all this time in school writing essays and whatever else, and the first thing that they try to teach you in college is actually how to write a proper email. That sounds silly, but if you look at the way you text and the way that we're expected to send emails, you don't get to shorthand at all. Matter of fact, it's a little bit embarrassing if you've got a couple of spelling mistakes in a key email, because you're dealing with a bunch of people you might not know or ever really see face-to-face necessarily in certain situations, because there's a work group. We might be working directly with the tradespeople, working as a go-between with the engineers doing project management. So that's one of those things that a lot of people take for granted these days, and like I said, it's the first thing that they start showing you in school is they expect a certain level of professionalism and a quality of the work that you put out. So it's something that it revolves a little bit around communication, but obviously that in your day-to-day life you take for granted. So we wanted to show that, like I said, we wanted to show you guys that there's career opportunities, but again, we want to reinforce that there are very good career opportunities in the technologies in our area. And as the years go by, it gets better and better. So, when I was in school, I guess I can tell you a little bit of a story. I signed up for design and drafting. I was hoping to take engineering. Looked at the U of A, looked at the cost, looked at Nate, and Nate was very, very good at explaining what the courses did, and there was a lot of practical application. So, I raced stock cars and dirt bikes. When I was a kid, I had a race car, and I wanted to learn how to build my race car properly. So how do I apply that to school? How do I get a job that helps me with that? Because that's what I do. And believe it or not, it looked like the best option on paper because it was a good balance between practical skill sets, like a lot of the things these guys do, and a lot of the, I guess, the engineering-based stuff. So the theory that goes behind it. So it was a bit of a go-between between the engineering path and the trades path. It's a nice balance. And when I signed up, I remember my parents saying, what do you want to do? You signed up for engineering, design, and drafting. Are you going to draw for a living? Is that what you want to do? And I said, well, it's not quite that simple because the engineering part of it is as big or bigger than the drafting part, depending on which career path you take. So that's something to consider too, is the practical aspect of what we do is just as important as the theory, if you will. Who in this room likes to play video games? Raise your hands up and hold them there. Anybody like to ride quads, dirt bikes, sleds? Oh, okay, almost got them all. Keep hands up. Anybody here like to build stuff? Okay, all right. Okay, keep your hands up. I think we almost got them all. Who here likes to interact, visit, go visit friends, do stuff, talk, chat? I don't see your guys' hands up, so you must hate all this stuff. Hate it, and I'm going to target you now because you're not playing ball with us. Anybody like to travel? Okay, perfect. Anyone, maybe an odd helicopter flight in the group here or anything like that? I basically think I see everybody got a hand up at some point here when I was asking that. All the things I just asked you are all things that we do on a day-to-day basis. That's part of our job. All of those things that we do are actually physically things that we use in our day-to-day work.
Some video games.
Well, the video games kind of relate to the CAD loosely. So, I mean, ultimately that's part of our job is one day we're sitting on the computer and we're drawing something. The next day we're driving a quad down a pipeline right away to do a survey and scouting. And then maybe the next day we're working with the construction management crew and we're visiting with a bunch of guys that we grew up with in high school. So I just wanted to point out that a lot of these things that you guys do on a day-to-day basis that you find interesting are things that are actually part of our job and that become part of your career, that realistically are things that we do on a day-to-day basis. There's a couple of shots here. This is a wireline crew. I used to do wireline work for a living, designing downhole tools and stuff. Worked at Syncrude. I pointed out that there's careers in Grand Prairie, and I guess it's worth noting that because of what I did personally for a career path, I've worked all over the planet, and I've done that from Grand Prairie. We were designing downhole tools, and because it was a very good quality piece of equipment that we were designing, we distributed all over the world. So I've been able to travel to South America, did a whole bunch of work in Asia. This is actually up in just south of, just kind of off the Alaska border. We did some fly-in work. So just because you're in Grand Prairie doesn't mean you're not going to get the opportunity to go somewhere else. And as a matter of fact, between me and Eric, we probably know half a dozen or a dozen guys that have traveled worldwide.
Yep.
And everywhere from the far reaches of Russia to, I know a guy that's actually based in Angola right now and lives in, I believe he lives in Wembley. Because of the quality of the talent in the oil and gas industry in this area, there's a lot of people from here that become specialists, that become very good at a very specific skill set within their trade or I guess their technology background, and they get the opportunity to travel. If you work for one of these big companies, Big Red, Big Blue, not going to name any names, they're huge corporate entities. You get a good job there, you build up your skill set, they're going to ask you eventually, do you want to go to Australia to work? Would you like to transfer to the southern United States? We have a job opening in Singapore. Would you like to travel? And when you're young, if you have the aptitude and the willingness, just like these guys said, if you got the drive to get into industry early and really work and apply yourself, there's a lot of opportunities. And like I said, they're right from here. You don't have to move away from Grand Prairie. You don't have to move to the city. You don't have to do any of that. You just got to be good at your job. And that allows you opportunities that you might not expect to see there.
To touch base, we have to really interact with a lot of people here. Like Jared said, it will come up to vendors, field personnel. We have to really know that we'll get this job in the right direction. So we're talking to various parties to ensure the job gets done. When it comes to even writing like bid documents, it's not going to be simple documents that you're going to be writing. It's more of a binding contract if you're awarding a job to a certain contractor or vendor. So you'll have to really be pretty fluent, communicate well. Really, all in all, you're trying to design and satisfy the needs of a client to ensure everything is addressed through all regulatory codes, standards, pretty much all government regulatory components, and to ensure that you have a cost-effective and design-effective layout for the job.
As Jared said earlier, I came all the way from Newfoundland to work here in Grand Prairie, so obviously there's a lot of job opportunities. So right here, this is called a plot plan. So this square that you'll see right here, this is what we'll start out with when we're designing the well site. So all we're given, these two little black dots are our wellheads, and this list right here, all we're given is our wellhead locations. So from our wellhead locations, we obviously have to have a lot of discussions with our own team and our clients about the materials used for the piping, the equipment we're going to need on site, and all this depends on a lot of factors such as the flow at the wellhead, the pressure at the wellhead, and safety factors. Our wellheads are right here, and after all the discussions and when everything is taken into consideration, we place our equipment in the most efficient layout, and we also have to take into consideration the access roads, so operators and also construction of the site can have proper access to all of the equipment. The P90s, which are piping and instrumentation diagrams. So as you can see here, this is our wellhead. And coming off our wellhead, there's valves. There's an ESC valve. There's a sand filter. There's many different types of valves and equipment that, as I said before, you have to take into consideration all the factors like the flow and the pressure at the wellhead.
And just as a side note, guys, this drawing that she's producing right now actually ends up in the hands of the tradespeople. So that's why we say that we have to interact with everyone, because the engineer provides a spec for us, or the facilities guys at the client level. We work with them, and then the trades guys get involved, and we actually, it's basically a big circle. Everyone's working together, communicating through emails and through meetings to try and establish all these things. So by the time she actually gets to working with that stuff, it's likely that the tradespeople have got their hands on the drawings as well.
So once you actually design a site, what's really interesting about this job, it's not all in the office. You'll design the site and you'll have discussions with your client and your team in the office. But once your design is actually approved and it's getting constructed at site, you can actually go out and you can see your own design getting constructed in the field, which is pretty interesting.
And to give you guys a little bit of an idea of what we're dealing with, we talk a lot about pressure and things like that. I don't know the exact number, but I think the human body can only sustain something in the order of about 300 or 400 psi, and that's like a deep sea diver, somebody that does the free diving or something like that. Most of the average wellhead pressures we're dealing with are well over 5,000 psi, so that's really hard to visualize, but if you could imagine with that, if you applied that amount of pressure to, say, an aluminum can, you could probably crush it to the size of your thumb. And that's the kind of, when Eric talks about safety factors and regulations, part of our job is to make sure that things are right, and that's why, because when you have a mistake within the design, the potential is for a release, and a release when you have that much pressure in a piece of pipe can be pretty significant, and obviously, so that's the kind of serious part of our job, the engineering and the due diligence part of our job. But that being said, it is pretty neat to see some of the things that happen to pipe under pressure. If you get sand wash in pipes and stuff, you can imagine sand is as abrasive as it is. You'd never imagine it actually digging a hole in a piece of pipe or anything like that. And we get to deal with a little bit of that. We get to see a little bit of that, and it's fairly interesting stuff on the technical side.